Alright, using related rates to solve problems involving distance. Alright, so here we have a 20-foot ladder rests against a wall with the bottom of the ladder 6 feet from the wall. If the bottom of the ladder is being pulled away from the wall at 6 feet per second, how fast is the top of the ladder sliding down the wall? Alright, well I guess the first thing we should do here is let's draw our wall. And then we have a ladder resting up against the wall. Alright, so we know that the ladder is going to be 20 feet. We are told the bottom of the ladder is 16 feet away from the wall. And we know that the bottom of the ladder is being pulled away from the wall at 6 feet per second. So this is going to be being pulled away at 6 feet per second. And we want to figure out how fast the top of the ladder is sliding down the wall. Alright, so now we have to figure out what formula we're going to use here. And by first looking at this is tricky, like what formula would we actually use? Well, if we're looking at it here, we have a right triangle, and we are dealing with just the sides of a right triangle. And when we're dealing with just the sides of the right triangle, the formula that should be coming to mind is Pythagorean theorem. So, a squared plus b squared equals c squared. So let's call the base A. Let's call the height B, and then the hypotenuse C. And remember, A and B don't matter, those are just the two sides. However, C has to be the hypotenuse, and we know it's the hypotenuse because the hypotenuse is always opposite the right angle. Alright, so next up we can figure out which one of these change with respect to time. Well, we know the base, the ladder is sliding away from the bottom, so therefore A changed with respect to time. B is changing because the ladder is sliding down the wall. However, C is not changing. The ladder is going to remain the same height, or the same 20 feet, so that's just going to be C squared. Alright, so now we can take the derivative of both sides. So we're going to have, let's see, we do need to use the power rule and the chain rule, so 2 times the front. So this is going to be 2 times a of t times dA over dt, plus, same thing with b, power rule, move the 2 to the front, subtract 1 from the exponent. So we're going to get 2 b of t times dB over dt, and equals, well, c is not a function of time, so therefore c is a constant, and a constant squared is just a bigger constant, I guess unless it's a fraction, but c squared is also a constant, and the derivative of a constant is 0. Alright, so now we are left with 4 variables. So we are left with a of t, dA dt, b of t, and then dB over dt. Alright, so let's just look and let's think about what does A represent? Well, A is the distance from wall at a specific time. D over dA is the change in distance from wall. B is the height of ladder at a specific time, and dB dt is the change in height of ladder. All right, so what do we know? Well, we know that A of t is going to be 16. So this is going to be 16. We know that dA dt is moving away at a rate of 6 meters per second. However, we don't know the height of the ladder, and we don't know the change in the height of the ladder. However, we're trying to find the change in the height of the ladder. So the only variable that we're missing is the height of the ladder at a specific time. So how do we figure out what that is? Well, let's start off with our triangle. The two distances that we do know, as we know the ladder is 20 feet, and the distance from the wall is 16 feet. And we don't know the height of the ladder on the wall. But we do have a triangle here, which means we can use the Pythagorean theorem again here to solve this problem. So we can do question mark squared plus 16 squared equals 20 squared. So I'll have question mark squared plus 16 squared is going to be 256 equals 400. So then we can just subtract 256 from both sides, and we're going to get question mark squared equals 144. Take the square root of both sides, therefore question mark is equal to a positive 12. So now we know that part. And now we can plug all these values into our derivative and solve for the one we're missing. So let's see, we're going to have 2 times 16, and then times dA dt, which is going to be 6, plus 2 times b of t, which we found out is going to be 12, dB over dt equals 0. And now we just simplify and solve using algebra. Calculus is done. So 2 times 16 times 6 is going to be 192 plus 24 dB over dt equals 0. I can subtract 192 from both sides. Will give us 24 dB dt equals negative 192. Divide both sides by 24. And we get negative 192 over 24, which can simplify down into 8. So that means it is going to be negative 8, feet per second. So the ladder is sliding down the wall at negative 8 feet per second. All right, so next up we have another example here, and this is also involving distance. So a police car traveling south towards Sussex Falls at 160 kilometers per hour pursues a truck traveling east away from Sussex Falls, Iowa, at 140 kilometers per hour. At that moment in time, the police car is 20 kilometers north, and the truck is 30 kilometers east. Find the rate at which the distance between the two vehicles is changing. All right, so we know we have Sussex Falls, and we have a police car traveling south towards Sussex Falls. So I actually wrote my Sussex Falls in the wrong spot, because the police car is traveling down towards Sussex Falls. And then police, the popo. And then at the, and then a truck traveling east, traveling away from Sussex Falls. Boom, 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 boom. And then we have, and for some reason I wrote trick. So truck is going east, away from Sussex Falls. And we want to figure out how much or how fast the distance in between them is changing. So hopefully you can see here that we just formed another right triangle. So we're going to use the formula a squared plus b squared equals c squared. So let's call this a and b, and our hypotenuse is c. So in this particular problem, all of our a, b, and c are changing. Everything's moving all at once. So this is going to be a of t squared plus b of t squared equals c of t squared. And then we can take the derivative of all these things. So we're going to have 2 a of t times dA over dt plus 2 b of t times dB over dt, and that is going to equal 2 c of t times dc over dt. All right, so now we have these 6 variables. So we have a of t, dA over dt, and then we have b of t and dB over dt. We also have c of t and then dc over dt. All right, let's see. What do we know? Well, we know that b represents the police car, and we know the police car is going 160 kilometers per hour, so dB dt is going to be 160. We know that the truck is traveling at 140 kilometers per hour, which is a, so dA dt is going to be 140. At this particular moment in time, we know the police car is 20 kilometers north, and the truck is 30 kilometers east. And our overall goal is to figure out what the distance between them is changing, or dc dt. So the only thing we need to figure out now is our c of t value. And I drew that circle too small. And again, this is where the Pythagorean theorem comes into play. So we can draw our triangle. We know that the truck is 20 kilometers, the police is 30 kilometers, and we need to find the hypotenuse. So 20 squared plus 30 squared equals question mark squared. So this is going to be 400 squared, or excuse me, 400 plus 900 equals question mark squared. So this is going to be 1300 question mark squared. So therefore our question mark, or our hypotenuse, is going to be positive square root of 1300. And we are just going to leave it as that. Square root of 1300. Alright, so now we can just plug and chug. So let's see, we're going to have 2 times 20 times 140 plus 2 times 30 times 160 equals 2 times the square root of 1300 times dc over dt. Alright, then we can just go to town. So let's see. 2 times 20 times 140 is going to be 5,600 plus 2. Oh, just dropped my calculator. Plus 2 times 30 times 160 is going to be 9,600. And this is going to be 2 radical 1300 dc over dt. Alright, so let's see. 5,600 plus 9,600 is going to be 15,200 equals 2 radical 1300 dc over dt. So that means that dc over dt is going to be 15,200 divided by 2 radical 1300. And then we can simplify this down to be 7,600 all over the square root of 1300. And let's see, this is going to be kilometers per hour.